Hello students, welcome back to Madhvi's Java programming tutorials. In this video, I'll explain branching or jump statements in Java. Let's see the contents: introduction, the break statement, Java programs related to it, continue statement and programs, return statement and programs, revising all three jump statements. Let's start. We have seen so far three different control flow statements. One is simple or sequential. Second one is selection, that is based on a condition. Third one is iteration statements. And fourth one, right now, we'll be discussing branching or jump statements. They send the control from one part to another part of a program or stops the execution of the program. There are three branching statements: break, continue, and return. The break statement transfers control either from loop or a switch case construct. Now, when break statement occurs, the program sends the control out of the loop or switch without seeing the condition part in loops. Let's see two examples here. In a for loop, we have used break statement, void display for int I is equal to 1, I less than 10, I plus plus. 9 times it is supposed to work, but some condition is there. If some expression, if that is true, break means even if the loop is a second iteration or third iteration or fourth iteration, any iteration, break sends the control out of the for loop. That is, next statement after the for loop gets executed. The moment break comes, control will be sent out of the break. In the second example, switch case, which we have already seen, break means send the control out of the switch case. Now let's see some Java programs. Let's understand the contents of demo break class, in which there is one static method and one statement, which is a simple statement displaying a message loop to work for 50 times. And there is a loop, a counter variable j starting from 1 to 50, it is supposed to run the loop. And system.out.println j, whatever is there in j in each iteration, it should display 1 to 50. But there is one statement: if j is 5, break, come out of the loop. Although it is supposed to work for 50 times, break takes the control out of the for loop, and outside the for loop, another simple statement is there, but worked 5 times because of break. Let's execute this program and see. Work 50 times is the method. Loop to work for 50 times. 1, 2, 3, 4, 5. Break is there. So, but worked 5 times because of break. This is the output. Break does not see what is the condition, nothing. It transfers the control outside the loop. Let's see prime check program. In the previous videos, I have taught you how to write a prime number starting from 1 to n. N may be 1000, 15, or 5. Let's see three scenarios: 1000, 15, and 5. If 1000 modulo j is equal to 0, count plus plus. So every time there is a divisor, then counting. 1000 is divisible by 2, 1000 is divisible by 5, 10, so many numbers. Keeps on counting in the for loop till n. That means if input is 1000 times, 15, 15 times, 5, 5 times. And outside the for loop, if at all count is exactly 2, why? Prime number has 1 and the number itself as factors. So prime number 5 is having 2 factors, whereas 1000 and 15 are having more factors. For example, 15 has 3, 5, 15, and 1, 4 factors. So it keeps on counting. And if at all count is 2, then only prime number, not a prime number otherwise. This program unnecessarily works so many times that its time complexity is more, 1000 times. We can change this program because we know jump statement, that is break, so far. So let's see this part of the program. Control K. What we are trying to do is, let me delete this part. N is red, count is 0. We are running the loop 2 to n by 2 times. Why? Because 1 is neither prime number nor composite number. So 2 to n by 2. N by 2 means if the input is 1000, it works only, n by 2 means 500. But we are starting from 2, so 499 times. If the input is 15, 15 divided by 2 is 7. 7 minus 1, 6 times. 5 divided by 2 is 2 quotient, and minus 1 only 1 time. So here only we are trying to reduce the time complexity. Not 1000 times, but 499 times in the first case. That is when user input is 1000. And also we want to further decrease the number of iterations with the help of break statement. How? If at all n is divisible by j, that means we are not considering 1. We are starting the loop from 2. We are not considering the n, that is the number itself. If at all the number is divisible by any other number other than 1 and n, immediately we know it is not a prime number. That's what our human brain does. So if the number is 1000, 1000 is divisible by 2, so not a prime, but count plus plus, because at the end we want to check prime number or not. We have printed not prime, but count plus plus tells the system that other than 1 and 2, 1 and the number, there is another factor which came. So count will be 1 and then break, come out of the loop. So instead of working 499 times, it worked only 1 time because 1000 is divisible by 2, so break, come out. Time complexity is decreased drastically from 1000 to 499, from 499 to just one iteration of for loop. This is the power of break statement. And after come out, we'll check. If still count is 0, then prime number. Let's dry run with 15 number. J is to j less than equal to number divided by 2. So 6 times it should work. Okay. 15 modulo 2. Is 15 divisible by 2? No. So j plus plus. Is 15 divisible by 3? Yes. Immediately, not a prime number. Count plus plus, count becomes 1. Break, come out. If count is 0, no, count is 1. So it will not print prime number. Already not prime is displayed. In case of 5 as input, we are starting the loop from 2 to n by 2. 5 divided by 2 is 2 only. So 2 to 2, that means only one time. Is 5 divisible by 2? No. Then 3. 3 is not less than 2, so comes out of the loop. By the time my count is not changed because the control did not go into if. So count is still 0. So prints prime number. So break statement actually reduces the time complexity. Let's execute this program. Still this program has error because we did not consider 1. We will understand considering 1 in return statement. Okay, control K. And then prime check, void check. Let's suppose we gave 1000 and it is saying not prime, just very fast because we have reduced the number of iterations. Void check 5 prime number. So this is about break statement. Now the same we can use in HCF also. HCF we have written int I is equal to 1, I less than equal to min, I plus plus, if A modulo I double equals to 0 and B modulo I equals to 0, H is equal to I. This program I have explained in the previous video. We are starting from 1 to min. We can write like this also, min to 1, I minus minus, and break. Because the highest common factor, let's suppose A is 5, B is 15. The minimum number is 5. And highest common factor for both of them is 5 only, that is minimum only. So as soon as we get a factor in the loop, that is the highest because we are going in reverse order. So break. But in both of the cases, break may not work properly because if the input is 2 prime numbers, in that case, what happens? The common factor is only 1. So the loop has to work till 1. Similarly, in prime check also, if user input is a very large prime number, it has to go through all the iterations. But wherever possible, break statement transfers the control out of the loop. This is about break. Let's understand continue statement now. Continue keyword is used in loops. It forces the next iteration by skipping the current one. That means it forces early iteration of the loop. When continue statement is executed, the control goes back to the starting of the loop without executing the rest of the statements after the continue statement. Now the loop control variable gets updated and checks the condition. If the condition is true, then the body of the loop will be executed and this process continues. Look at the example. Control variable CTR is equal to 1, CTR less than equal to 5. This particular loop should work 5 times and one statement is hello, second statement is mic testing. But if control variable CTR greater than or equals to 3 and less than equal to 4, continue means the control is transferred back to the for loop. What would be the output when control variable CTR is 1, hello and mic testing? Second time also hello, mic testing. Third and fourth iterations, continue statement is there. That's why just hello printed twice. And in the fifth iteration, hello, mic testing. Continue forces early iteration of the loop. Let's see a Java program. The same program, this loop is supposed to work 5 times. And inside for loop, there are 1, 2, 3, 4 statements. 2 statements are one condition, second one is continue. That means when the iteration number 3 and 4, mic testing will not be printed. But for iteration number 1, 2, and 5, mic testing would be printed. I just have added CTR, that is iteration number, so that we come to know. In 3 and 4, no mic testing because early iteration of the loop happens over here. So let's execute. See, first iteration, hello, mic testing, hello, mic testing. 3 and 4, because of continuous statement, no mic testing printed here. And in fifth iteration also, it is printed. This is what is continue. Let's suppose we want to display sum of positive numbers by accepting 5 positive numbers. But if at all user enters either below or equivalent to 0 or above 100 or equivalent to 100, then we don't want to add the sum. This is the condition. Program to add 5 positive numbers between 0 and 100. 0 and 100 excluded. Enter 5 numbers. These are all simple statements. Now, iterative statement. In that, we are accepting n. Reading n how many times? 5 times. But if at all that number user input is less than or equal to 0 or greater than equals to 100, continue, force the early iteration. Otherwise, add n to the sum, that is accumulator variable. And then print sum of positive numbers, sum. This is also a simple statement. Here it is a jump statement. If n less than equal to 0 or n greater than equals to 100, continue. Forces early iteration. Let's execute and see. As long as we are giving, see, let's suppose 5 numbers, 1 is entered, -1 should not be added. 5, okay with us. 101 should not be added. And then 3. See, sum of positive numbers is 5 plus 1, 6 plus 3, 9. It did not include 101 as well as -1. So continue can be used like this also. And divisibility can be written, the program can be written in different ways. In this program, we are accepting a range A and B, starting a loop from A to B and incrementing by 1. If this number modulo 3 not equal to 0, if it is not divisible by 3, continue. If it is divisible by 3, it goes to the next statement because if is false. False means continue will not be executed, but prints I. So A and B is the range. In between the range, all the numbers which are divisible by 3 are printed. So let's execute this. Range is, let's suppose 1 to 100. All the numbers which are divisible by 3 are printed over here. 3, 6, 9, 12, and so on and so forth. This is about continue. Let's see return statement. Return statement sends the control out of a method. It can be used in 2 ways. Can be used to stop the execution of the program or return the control from a subprogram to the calling program, either with value or without value. With value concept is discussed in user defined methods, but we will understand how to use return statement. See, look at this program, class demo. Main method is there. If some condition is true, return. That means from main method, control is going back. That means stopped. The program is stopped. Or if that condition is not true, then goes to the next statement, that is system.out.println, calling another method check. So control goes to check method. If some expression return, goes to the calling program, goes back to the calling program. In the main method, return means stop the program. In the check method, return means go back to the calling place. Similarly, class demo 1, from main method, if some condition is true, return, stop the program. Otherwise, look at this string check, not void check. In class demo, it is void check. In class demo 1, it is string check, means string is being returned. This concept I'll explain in user defined methods. So, return a string, Java is returned to the calling place. This is how we use return statement. Let's see a program. Let's see the same prime check program, but using return. So prime check, we are reading a number, count is 0. If at all n is 1, not a prime number, return, stops the program. Otherwise, whatever is there in prime check, that program which we have written, j is 2, j less than equal to n by 2, j plus plus, if n modulo 0, then not a prime, count plus plus, break. This part, what we do, copy and paste it here. And then control K, the same program which we have understood, but added one extra n is equal to 1 return. Now let's execute the program. Prime check, enter a number it is asking. Let's say we said 2 prime number, fine. Minus 2, also prime number. Okay. And then 1, not a prime number. Any other number other than prime number, maybe 8, not a prime number. So this is the full program. With the help of branching statements, we can write proper programs. This is reducing the time complexity. This is using return statement, and we can run the loop with lesser number of iterations. And then the next program is print result. Although I explain this in user defined methods, enter marks. Marks are read. If at all marks less than 0 or greater than 100, invalid marks, return, stops the execution. If marks are in between 1 and 100, then calling a method called check and passing m, the marks, let's say 45 marks or 90 marks. 90 marks, the check method will be executed here by sending 90. This m will send 90 to marks. So if marks greater than equals to 40, yes, 90 is greater than 40. Congrats, passed will be displayed. If marks less than 40, sorry, failed will be displayed. This is method calling and returning. We are returning a string here. What is that? String. Congrats, passed, return. This concept we will understand in user-defined methods, but let me execute the program. First time we give either less than 0 or greater than 100, then stops the execution. Otherwise, it prints either congrats or sorry, failed. Okay. Void main and then execute. Let's say first time we are giving 104. Invalid marks, the program stopped. And then if we execute second time, giving valid marks, but above 40, 90 marks given result, congrats, passed. What if we give below 40? Then let's say 30, sorry, fail. This is how we can use return statement to stop the execution or return value or just return the control. This is about jump statements. Let's revise the jump statements. 3 branching statements: break, continue, and return transfers control out of a loop or a switch. Break transfers control out of a loop or a switch. Continue forces early iteration, and return transfers control out of a program with or without value. Now break from for loop outside the for loop, and then continue forces early iteration. Return sends the control out of the method. Refer chapter 8 of Basics in Computer Applications for practice exercises. And the next video is about nested loops in Java. Thank you.